Hello, everyone. It's great to see you guys joining early. Stay tuned. We will be starting shortly.
Hey, hi Raksha, can you hear me?
Yeah. Hi. Thank you so much for joining early.
Okay,
We will be starting shortly.
yep,
Let's wait for a few minutes more.
yep, sure.
Hello, everyone. Welcome to another session of the DataHour series. We will start the session at 3 p.m. IST, and soon I will be sharing two polls. So make sure everyone to participate in. Till then, let's get to know each other in the chat section. You can start with your location. Hello, Smriti. Thank you so much for joining. Okay, so guys, I'm shooting two polls here. First one is regarding your location, and the other one is to know your experience level in this field. So, which I want everyone to engage with. everyone make sure to participate in this poll so that we can get a better idea of your experience level. And in a few minutes, we will start with the session. Okay, so I guess we are good to go now. We have enough participants. So everyone, good morning, good afternoon, and good evening, respective of the locations you are joining us. Welcome to another session in the Data Hour series. We are thrilled to have you here for an interactive learning session. I, Raksha Nagaria, am the part of data science team at Analytics Vidhya and will be the moderator for today's session. For those who have joined us for the first time, a brief introduction about the Data Hour sessions. With the intent to make data science learning more engaging to the community, we began with our new initiative, DataHour. DataHour is a series of webinars led by top industry experts where they teach and democratize data science knowledge. So now on to our session today, which is Introduction to Network Science. Network science is the study of patterns in interconnectedness of multiple entities. So these entities can be from any domain. For example, friends from a network of friends in social media and many more. Network science is applied in multiple domains to uncover internal structure of a complex system, and also in many other applications like recommendation system, community detection, modeling, spreading phenomenon, etc. In this data hour, Bhaskarjit is going to cover a detailed introduction to network science and its different centrality measures. He's also giving to discuss various business use cases of network science. So before we kick things off and I introduce the session presenter, a quick recap of the housekeeping items. We are recording this session and we will make the recording available in a few days on our YouTube channel. Please use the Q&A section for asking any questions you might have during the session. As the data hour progresses towards the end, we will do our best to answer them. Also, we will share a feedback poll towards the end of the session, which I request everyone to participate in. Now, onto our speaker in this session of Data Hour, we have Bhaskarjit Sarma with us. Bhaskarjit Sarma is currently a data scientist at BlackRock who builds predictive models for solving asset management business problems, including trading, lending, risk management. And his main research areas are explainable AI, uncertainty, network science, NLP, and computer vision. He's also built computer vision and NLP applications to solve customer problems in various domains. Apart from this, he also loves teaching and mentoring data science aspirants. So over to you, Bhaskarji. The virtual stage is all yours.
Yeah, thank you so much, Raksha, for the introduction. And I would like to welcome everyone to this data hour session on network science. And today, network science is a very vast area, and it is used in many different, domains. So we'll just, I'll just introduce the topic to all of you so that you know what is network science, what are different use cases that industry professionals are trying to solve, and what are different machine learning algorithms that can be applied on top of network. And I'm sure you must be having some questions, and you can park your questions towards the end of the session. So I'll spend around 40 to 45 minutes to introduce you to this topic, and then later on we can have few minutes for Q&A. Okay, so let me share my screen and yeah. Okay, I hope all of you can see my screen. So here today I'll mostly talk about introduce what is network science. I will introduce network science to you, and then I'll also talk about network science use cases. So you must be thinking about where network science can be useful. So network science is used in many different domains. For example, social networks, social media. Let's talk about Facebook, or talk about Twitter, or any other social network. So network science is very widely used to, for example, in Facebook uses friends you may know. So how they find out which friends you may know. So that's an application of network science. Then in communication network, in financial network, for example, let's talk about you do trading and you want to find out how different stocks in your portfolio, they are related to each other. If one stock in your portfolio goes down, then what will be its impact on the other stocks in the portfolio. Then biological network. So recently DeepMind, they have built a graph neural network which can unfold all the protein structures that are in the world, that are in the literature. So again, graph neural network has been helpful in that particular domain as well. Then collaboration network, internet network, temporal network, and so on. Even in supply chain as well, network science is widely used. Even in HR or people analytics, you might want to identify the employee network, which employees are very important for you, based on some other definitions of importance in the network, which I will explain in detail. So here, this is an example of a network, a financial network. So here on the left hand side, what you can see on my screen, this is a correlation matrix, and this is a correlation matrix of log returns of S&P 500 universe. So for example, if you have all those S&P 500 stocks like Google, Amazon, and all those another company, you can find out their close prices, end of day close prices, and then from those end of day close prices, you can find out the returns of those stocks, day over day returns, and from that return you just find out correlation. And this is how the correlation matrix looks like. Now to create any network from a structural data, so this is a structured data which you can represent in a form of a table. So to create a network from this structure, so you first need to identify what will be the nodes and what will be the edges between the nodes. So for example, here on this network, there's all these blue dots. These are the nodes, and all those edges which connects between these two, all these lines that you can see connecting these two nodes, they are known as edges. So what attribute or what data or what information you want to capture here? So based on that, you need to convert your correlation matrix or any kind of matrix into another matrix called adjacency matrix. So here we have used the correlation matrix as our adjacency matrix, where each and every nodes will be a stock, and each and every edges between these nodes will contain correlation coefficient, that is rho. So here, this blue colored matrix, so these are all correlation coefficient which lies between negative 0.25 to 1. And this correlation matrix we computed for the entire year of 2021. So now once you get this particular network, then what information you can find out from here? Okay, so what feature you can find out from this network? So there are many features that we can find out from this kind of networks. One type of feature is known as graph level feature, that what is the diameter of this network, what is the average shortest path of this particular network, what is the clustering coefficient of this particular network. These are known as graph level or network level features. And there are certain other features which we call it as a node level features. Okay, so let me explain some of the node level features, and then I can give you some more meaningful insights. How in different domain, what can be the meaning of this node level features in different domain. So for example, here let me open up a blank slate. Yeah, so for example, let's say I have a network, and this is a network of these many nodes. Okay, let me draw this network. So here, all of these networks are connected to each other like this, in this way. And here, let me name some of these nodes. For example, let's say this node is node number 1, this is node number 2, and this is node number 3. So if I ask you, out of this, 3 nodes, which node is most important? Well, some of you might say node number 2 will be most important, or some of you might say node number 1 or node number 3 will be most important. So actually, the answer to this particular question, actually, it depends on what is the definition of importance. Okay, so based on definition of importance, we have 4 different measures, which we call it as centrality measure. And based on those centrality measures, we can find out features for each and every node. The first measure is known as degree centrality. Okay, so what is the meaning of degree centrality? So degree centrality means that how many nodes you are connected to all the other nodes in this network. So if I talk about node number 1, it is connected to 4 other nodes in this network, 1, 2, 3, and 4. And if I talk about node number 2, then it is connected to only 2 nodes, 1 and 2. So its degree centrality is 2. If I talk about node number 3, then it is connected to 1, 2, and 3. So from degree centrality point of view, node number 1 is the most important, because node number 1 has highest degree centrality. So the meaning, the physical significance of degree centrality will be, how popular a particular node is. So for example, if you think of this network as a friend, your network of friends, then that particular friend or person who have high degree centrality, that means he or she has highest number of connections. So that means that person is very popular in the network. Okay, then the second definition of centrality would be closeness centrality. So what is the meaning of closeness centrality? That how far away each these nodes are from all the other nodes in this particular network. So if I want to find out closeness centrality for node number 1, so you can see that these 3 nodes, 1, 2, and 3, these 3 nodes are 1 degree separation away from node number 1. So that means total degrees of separation is 3 into 1. Then for node number 1, there is no separation against itself, it is blank. For node number 2 to 1, it is 1 degree separation away. For 3 to 1, there is 2 degrees of separation. So it is 2 over here. Now for this node, it is 1, 2, and 3 degree separation separated. Then this is 4, this is 5. Similarly here as well, this is 3, 4, and 5. So it will be, the total degrees of separation will be 3 plus 4 plus 5. You multiply it by 2. So here it becomes 3 plus 4, 7 plus 5, 12 into 24 plus 3, 27 and 30. So it has 30 degrees of separation for all the other nodes in this network. Similarly, if we do for node number 2, then it is 1 and 2. So there are 3 nodes with 2 degrees of separation. 1 and 2 is 1, 2 against itself, there is no separation. And then 3, 2 is again 1. This is 1 and 2, then 3, then 4. So here it will be 2 plus 3 plus 4, then you multiply it by 2, then that becomes 5 plus 4, 9, 2, 12, uh, 18. 18 plus 2 is 20, then 26. And the last will be for node number 3. So for node number 3, these 3 nodes, 1, 2, 3 degrees of separation away. So 3 into 3. 1 is 2 degrees separation away. 2 is 1 degree. Then 3 against itself, there is no separation. Then here it is 1 plus 2 plus 3. Then again for the bottom 3 nodes as well, 1 plus 2 plus 3, and you multiply it by twice. Then 1 plus 2 plus 3 is 6. 6 into 2, 12, 12 plus 3, 15, 15 plus 9 is 24. So if you see, node number 3 has less degrees of separation. And if you want the closeness centrality number, the numerical value, it is just reciprocal of this number. So out of these 3 different nodes, node number 3 has highest closeness centrality. So, okay, so mathematically you understood, okay. Can you please tell slowly? Okay, yeah, let me go slowly. So the calculation, I hope degree centrality is clear to everyone. The closeness centrality meaning was, so for example, if you talk about this particular node and you want to identify closeness centrality for node number 1, 2, and 3, then you find out how many degrees of separation it is from this particular node. So there is only one edge or one connection. So this node is only 1 degree separated away from node number 1. Similarly, this node as well, there is 1 degree separation. This node always 1 degree separation. So for this 3 node, you just multiply it to 1, 3 into 1. Then 1 against itself, there is no separation. Then for node number 2 to 1, there is only one edge. So you multiply, you put it 1 for node number 2. For node number 3, it is 1 and 2 degrees separation away. So you put it 2 here. Then for this node, it is 1, 2, 3 degrees separation away. For this node, it is 4 degrees separation away. And for this node, it is 5 degrees separated away from node number 1. So you similarly for this 3 nodes will also be 3, 4, 5. So you add these numbers, 3 numbers, and you multiply it by 2 because we have 2 sets of these data points. Okay, and then you add up all these numbers, and when you add up all these numbers, you get 30 for node number 1. So similarly, you do the same calculation for node number 2 and for node number 3. So when you do the same calculation for node number 2, you get 26, and for node number 3, you get 24. Okay. Okay. Mouse pointer is not visible. Is it for everyone? Mouse pointer is not visible. Okay. Yeah. Okay, just 1 minute. Okay, I hope now it is fine, right? Okay, fine. So I hope the calculation is also clear now. Okay, so now if you see node number 3 has highest closeness centrality. So you understood how mathematically this is calculated, but what is the meaning of this? What is the physical significance of this quantity? So from the business point of view, you can think of, let's say you have a financial network, okay, and you do trading and you have a portfolio, and in your portfolio, let's say you have hundreds of stocks in your portfolio, okay, and you want to find out that which particular stock has highest closeness centrality. So if you have a stock which have highest closeness centrality, and if that particular stock have some idiosyncratic risk, then that risk can propagate through the entire network at a very faster rate, much faster rate. So closeness centrality is related to how fast information can spread through the network. Or for example, let's say if you're doing modeling on COVID, how COVID was transmitted from one city to another city, then what you can do, you can create a network of cities, and you can find out which city has highest closeness centrality, and whichever city has highest closeness centrality, that means the information or the virus has spread through that particular city at a much faster rate as compared to all other city that is present in the network. Or let me talk about another network. Let's say you have a friends network, okay, and you want to find out of all, let's say you want to spread some news, okay, you want to spread some news at a much faster rate, then which friend you should, inform this news to, so that the news spreads much at a much faster rate. So again, you need to find out from your friends network that which friend has highest closeness centrality. Okay, then similarly, so based on this name, based on this centrality measure or definition of centrality, closeness centrality, node number 3 wins the race. I mean, from degree centrality, node number 1 was the most important, and from closeness centrality, node number 3 is most important. Okay, then there is one more definition of centrality measure, that is known as betweenness centrality. Okay, so let me write it down here. Betweenness centrality. Betweenness centrality. So how betweenness centrality work is, so again, for example, let's say you are at this particular, at this particular node, and from this node you want to move to any other node in this network. So if you want to move from this node to this node, then in how many, or any other node in the network, in how many parts node 1 will appear. Okay, so in how many parts node 1 will appear. So if you talk about, if you, let's say you want to go from this node to node number 2, then 1 will appear in its path. Or if you want to move from this node to node number 3, again node number 1 will appear. If you want to move from this node to this node, again node 1 will appear. So what will the total count of parts where node 1 will appear if you want to move from this node to any other node in this network? So you just find out the total number of nodes on the right hand side of node number 1, and also on the left hand side of node number 1. That will be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So if you want to move from this node to any other node in this entire network, node 1 will appear 10 times. For this node as well, node 1 will appear 10 times. For this node as well, node 1 will appear 10 times. Okay, so that means, so for these 3 nodes, node 1 will appear 10 times. So I'm multiplying it by 10. Then for this particular node, you can find, you don't need to compute number of parts for the same node. So you go to node number 2. So if you want to move from node number 2 to any other node in the network, let's say you want to move from node number 2 to node number 3, node 1 will never appear in this path, right? So node 1 will appear whenever you want to move from node number 2 to any other node on the left hand side of node number 1, right? So here for node number 2, node number 1 will appear in 3 parts. Node number 3, node 1 will appear in 3 parts again. For this particular node, node 1 will appear in its path again 3 times, right? So for all of these nodes, node 1 will be appearing in 3 parts only. So that means what will be total count? One. So total number of nodes are 1, 2, 3, 4, 5, 6, 7, 8. For all of these 8 different nodes, node 1 will appear only 3 times whenever they want to move from this side to the left hand side, right? So you just multiply 8 into 3. Okay, so that will be 24 plus 30, so that makes it 54. Okay, so you do the same calculation for the remaining 2 nodes, node number 2 and node number 3. Okay, and when you do this calculation, you'll find out again node number 3 wins this competition or wins this race when it comes to betweenness centrality. Okay, so now you understood mathematically how betweenness centrality is calculated, but what is the physical significance of betweenness centrality? What does it mean from business point of view? So those nodes which have high betweenness centrality, they are known as gatekeepers or the brokers or the middle, or the glue which is combining all the network together. So let's say if node number 3 has highest betweenness centrality, and if you remove this particular node, then entire graph will disrupt, entire graph will break apart. And this kind of analysis is very much useful in HR analytics or in people analytics nowadays, because if you're aware of what's going on in job market, that's since last year the great resignation is happening, organizations are not able to retain talent. So if they can do this kind of an analysis on their employee network, and they can find out which are those employees in the network which have high betweenness centrality. Because if they have high betweenness centrality, that means if those employees leave your organization, then the entire network of employees will fall apart. Okay, so that's another use case of network science in HR or people analytics. So these are all descriptive uh, you know uh, these are all descriptive values, but again we can also go ahead and find out do some predictive modeling as well using machine learning. So let me show some of the use cases of this descriptive analytics of a network, and also show some of predictive analytics network use cases of predictive analytics on a network. Okay, so this is about some basic introduction to network. Let me show you one example. So this is an example of a recommendation system, and this website is known as connectedpapers.com. So this is known as a recommendation system for research papers. Okay, so what you can do here is you can write any paper. Let's say you have read an research paper, and you want to find out some other similar research paper which you have not studied or you have not read yet. Okay, so how does it work? So let me search any paper. So let me search any paper like liquidity analytics, for example. Okay, so if I click on this first, okay, not able to see screen. Okay, you're not able. Okay, let me share my screen again. Okay, 1 minute. Let me share my screen again. Okay, I hope it is visible now.
Yes, it's visible now.
Okay, yeah. So what I was explaining was, so this is a website called connectedpapers.com, and this is a kind of recommendation system for research papers. And here, what you can do, you can just search any papers that you have read. So, for example, let me search a paper on liquidity analytics, for example. Okay, and here you can see this is a paper titled "Optimization Algorithms and Investment Portfolio Analytics with Machine Learning Techniques under time varying liquidity constraint." So let's imagine if you have read this paper and you want some recommendations. So let me click on this. And when I click on this paper, you'll see a network will automatically get created. So this is a network of papers, and it is telling you that these are the recommendations for you. So this is recommendation number 1, this is recommendation number 2, this is recommendation number 3, and so on. And you can select whichever paper you want to read, right? So how it is working under the hood. So if you click on this question mark over here, okay, I'm again getting somebody saying screen is not visible. Is it not visible for everybody, or?
It is visible.
Okay, it is visible. Okay, let me carry on. Okay, so if you click on this question mark here, you will see they have mentioned that papers are arranged according to their similarity. Okay, so now how do you find out similarity between papers? Okay, so there are, for example, here this is one paper and this is another paper, and how do you find out similarity between papers? So here you need to again use some concepts from NLP as well, natural language processing, where you need to find out some vector or numerical representation of this text data, because machines actually they do not understand text. You need to convert the text you need to convert text into numbers, and that process is known as feature extraction. And there are lots of different feature extraction techniques out there in NLP, like TF-IDF or bag of words, or the current state of the art in the industry is word embeddings. So you can use word embeddings to create a vector representation of this text, and then you can find out distances between those vectors, and based on those distances you can find out if two papers have a very small distance, that means they are similar to each other, and if two papers have any huge large distance, then they are kind of dissimilar to each other. I'll show one more example similar to this in just few minutes. I think if you're not able to follow along, it will be clear in that example. But here, as I mentioned, so here the papers are arranged according to their similarity, and you can see some of the nodes are very small in size and some of the nodes are very large in size. So the size of the nodes are also having another feature, that is number of citation. And you can see some of the nodes are very light and some of the nodes are very dark. So this also, the color also is, you know, capturing another information about time, that if the color is very light, then it means it's a very old paper, and if it's very dark, then it means it's a very new or recent paper. And the last one is similar papers have strong connecting lines and cluster together. So if you see some, you know, edges, like for example, this edge here between this and this node, and if you see this particular edge here between this and this node, this edge is much, you know, stronger and or looks, you know, very darker, and this edge is much, you know, lighter. So here the edge between these two papers are actually capturing the similarity between them. Okay, and these kind of networks are also known as weighted network. Generally, there are many different kinds of network. One is weighted and unweighted. Unweighted means you just have a connection between them, no matter how strong or how weak that connection is. But here in this case, it's not like that. You know, some connections have very strong connecting lines, some connections have very weak connecting lines. So these are known as weighted connections or weighted, you know, network. Okay. So this is one example of when network science and NLP coming together to create a recommendation system. Now let me show you another example. So here, this is more advanced example using graph, you know, machine learning on network. But again, this is I don't want to go in detail mathematically, but I just want to show you once you get the output, then how you can use that output to solve a kind of business problem. So here, what we have done is, so whatever data point that you can see on my screen, there are approximately in total 1405 data points are there, and each and every data point is represented by a vector of dimension 50, right? And what each and every data point is denoting here, so if I hover over in data point, so these are all different movies. So this is a very famous movie lens dataset, and if you are aware of movie lens dataset, it has three columns, that is user, and then movie, and then rating. Okay, so using this particular, you know, data set, user, movie, and rating, we want to create a recommendation system. Okay, so here what we have done using this data set, we have created a representation, a vector representation. So this learning is also known as representation learning using graph machine learning. So here for each and every movie, we have created a 50-dimensional vector. Okay, now you cannot visualize a 50-dimensional vector on a computer screen, right? Because in a computer screen, either you can visualize 2-dimension, or at max you can visualize 3-dimension, or at max you can visualize 4 or 5-dimension using some kind of tricks, like using some kind of colors or shapes or size, right? But it's not possible to visualize 50-dimension in a computer screen. So that's why what we have done is we have converted this 50-dimensional vector into 3-dimensional vector using PCA, just to visualize, just to see patterns if there is any pattern in the data. Okay, and if I hover over any data point, let's say I'm, you know, let's say this movie or any other movie, let's say, yeah, for example, this movie. Okay, so if, for example, so when I selected this movie, it automatically selected 100 nearest, you know, data points, or 100 nearest neighbors, and these are these neighbors. Okay, and these are the neighbors in the original space. So what is the meaning of original space here? The meaning of original space is that this 50-dimensional space. Okay, and how they have find out nearest points in original space? There are two different kinds of, you know, quantities or, you know, measurement you can use. One is cosine distance, and another one is Euclidean distance. So if cosine distance is very small, if distance is very small, that means those items are similar to each other. Okay, so here that means this movie and this movie, they are similar to each other because their cosine distance is much smaller. Okay, and in the 50-dimensional space. Okay, so I got a question. Let me first finish and then I'll try to answer these questions. Okay, fine. So here, then the second one is Casper. So this is the second most nearest to this particular movie. Okay, so these are the nearest neighbors. Now, how you can use this information to build a recommendation system? So let's say, let's imagine there are two users. Let's say this is user A and this is user B. Okay, and both of these two users, let's say they have rated this movie as 5. This user has rated this movie as 5 out of 5, and this user B have rated this movie as 1 out of 5. So what does it mean is that A, okay, I am getting a message that screen is blank. Is it for everyone, or can you?
Our screen is visible. They
Okay,
can
okay,
check network connection.
okay,
Yes.
yeah, fine. Let me then continue. Okay. Fine. So here, as I mentioned that, let's say there are two different users, user A and user B, and user A rated 5 out of 5. That means user A has liked this movie, and user B didn't like this movie. That's why he or she has rated this movie as 1 out of 5. Then if we got this nearest neighbors for this query movie, that means we should recommend this movie to user A, but we should not recommend this movie to user B, because user B didn't like this query movie. That means user B will also not like this particular movie that we have got from this particular representation learning. Okay, so that's one way to build a recommendation system. Okay, then there is one more example. So this is not an example, this is a repository or resources. If you want anybody interested to learn more about network science, or you want to explore about different data sets on network science, so this is a group called Stanford Network Analysis Project, or SNAP in short. And they also provide you some large network data set where you can explore on your own. So for example, they have data sets on social networks, then they have data sets on information network, then communication network like email communication network, then citation network is which we already have seen here in this recommendation system. Then apart from citation network, you have collaboration network, co-authoring of a paper, then again web graphs, then Amazon networks. For example, which items are co-purchased or bought together. So when you go to Amazon or when you go to Flipkart for buying anything, then when you buy let's say you're buying a product A, and if you scroll down in the page, in the same page, you also see the customers who have bought product A, and they have also bought product B. So there is a connection between product A and product B, and you can create a network out of it. And when you create a network out of it, you can do any kind of network analysis on top of that. Then you have internet networks, road networks, even autonomous systems, sign networks, and so on. So you can explore this website to get any kind of data sets and play around with this. Okay, fine. Okay, so I'm getting few questions. Yeah, I'll answer all those questions. Just before I go back to Q&A, let me share with you one very interesting application. But again, I'll not go through the entire project because we don't have much time. I just wanted to give an brief overview. So here, this is an example where you can use network science to do portfolio optimization. So for example, here, let's say you want to create a portfolio, and you want to, let's say you are doing active investing, where you want to beat S&P 500, for example. And this entire network that you can see is S&P 500 universe network, where each of these nodes are stocks, and the edges between these nodes are the correlation coefficient. Okay, then what you can do, you can first get all the data. So data will look in this format, where you have dates, and for each and every date you have end of day close prices for each and every stock. And once you get this price data, from this price data you can compute uh, you can compute log returns, daily log returns, by just shift your data points by 1 day, and then you just take logarithm on top of your shifted data, and then you just subtract. That is the log return for you. And once you get log returns for all of these different years, for example, then you just find out correlation. And once you find this correlation, then you can create this correlation into correlation matrix. So this is how the correlation matrix will look like. So this is the correlation matrix for 2011, this is correlation matrix for 2012, and so on. This is the correlation matrix for 2020. And once you get this correlation matrix, you can create a graph, and this is how a fully connected graph will look like. So this is a 500 by 500 graph, where each and every node is connected to each and every node. Okay, so these are known as fully connected graph. And again, I remember one of you have asked in the chat that what is the library that we have used we can use for network. So for network science, the one of the very popular library that we use is networkx. Okay, networkx. So in networkx, you have all these functions like nx.graph, nx.centrality measures to compute, or nx. Community detection. All of those are inbuilt, which you can directly use in your applications. Okay. So you can see this network is actually not very useful because it is a fully connected network and it is also connected to itself, and that's how it has so much noise. So if you want to remove this noise, which we call filtering graphs, again we have many different ways to filter graphs, and MST, which is known as minimum spanning tree, is most popular way to filter graphs. But you cannot directly use minimum spanning tree on top of this graph which we got based on correlation matrix. So what we need to do first is we need to convert this correlation matrix into a distance matrix using this formula, that is square root of 2 into 1 minus correlation between those nodes or those stocks. And once you use this formula, you get the distance matrix. And on top of that distance matrix, you apply minimum spanning tree algorithm. Again, you don't have to write your own code because these algorithms are already present in networkx library, and you pass those distance matrices. And once you apply this minimum spanning tree on top of those fully connected distance matrices, now you get a filtered graph after that. And once you get filter graph, you can just show you how you can show how the filter graph looks like. So this is a filter graph which is not fully connected for the year 2011. This is for the year 2012, and so on. Okay. And once you get this different graphs, then you can start doing your portfolio construction. So here, to create this portfolio construction, first we're finding out all those quantities like degree centrality, closeness centrality, and betweenness centrality that we have discussed a few minutes back. So this is how the degree centrality of all the 500 stocks in this universe looks like. So if I just zoom into in this section, so you see this particular stock called Honeywell. Honeywell has highest degree centrality as compared to all other stocks in this S&P 500 universe. Then if I scroll down, so this is closeness centrality, and if I again zoom into this plot, so this for the stock that is PRU, that is Prudential. Prudential has high closeness centrality. And what is the meaning of closeness centrality? It means if you have any kind of, from financial point of view, if Prudential get any kind of systemic risk, then that risk will spread much faster in your entire portfolio as compared to any other stock. So if you're for example a risk manager, or if you want to manage risk of a portfolio, then you should look into this particular stocks very closely, or you should closely monitor this particular stocks, because once they get bad, then your entire network, there is a high probability that your entire portfolio will go down. So again, then next is the betweenness centrality. So if you scroll down and if I zoom into this particular chart, again you can see Prudential has betweenness centrality, then followed by AMP, then followed by LNC, and so on. So these are based on centrality measures. Then based on centrality measure, we have find out top 15 centrality or top 10 measures stocks. And from that, so basically you have degree centrality for each and every stock. You have betweenness centrality, average centrality, just summation of all the centrality measures. Then you also find out what are those which are those stocks which are at the periphery of the network, or which are at a farther distance away from the center of the network. Okay, so that's what we are calculating here, the distance from correlation criteria, distance from degree criteria. So distance from degree criteria mean that, let's say you have a node which has high degree centrality, then what is the distance of this 3M stock from that particular node with high degree centrality? So it is 2. So that means if I have high distance for a particular stock, let's say this particular stock ACN, its distance is 16 from that particular node which have high degree centrality, that means it will be far away from the network. It will not be at the center of the network, it will be at the periphery of the network. So based on centrality and based on distance, we are creating two different portfolios. One we calling it as peripheral central portfolio and peripheral portfolio. Okay, central portfolio and peripheral portfolio. So central portfolio means all those stocks which have high centrality measures, average high centrality measures, and peripheral portfolio contains those stocks which have high distance measures, which are or in other words, they're at the periphery of the network. So if we now invest same amount in all of these three portfolio, that is, let me show you this plot. So if we now invest same amount, let's say you have invested $100,000 on the central portfolio, which is this orange line, and the peripheral portfolio, which is this green line, and then S&P 500 blue line is the S&P 500 index. So on an, if you see for, and if you keep it invested for the entire year of 2021, you'll see that this orange one, which is the central portfolio, has significantly outperformed the S&P 500. And that means if your markets are stable, and which was 2021 was a very stable market, when markets are stable, if you invest in a central portfolio, then you have high chance of getting better returns than S&P 500. Okay, or if markets are down or markets are unstable, which is like right now what's going on in the world because of inflation and Russian invasion of Ukraine, in that scenario you should invest in peripheral network, because in those cases peripheral network outperforms the benchmark. Okay, so that is one use case which I wanted to highlight very quickly, and you can use this kind of analysis using a network of any financial securities. Okay, so yes, so now let me go back and take few Q&A. So yeah, so is there any, Raksha, do you want me to take any specific question, or should I go ahead one by one?
Yeah, we can go ahead one by one. We
Okay.
can check it in Q&A.
Okay, fine.
Yes, also actually before taking Q&A, I would like to share feedback poll. So for 2 minutes.
Yeah, sure. Yeah.
Until then, we can take a few questions in between.
Okay. Yeah, so I'm taking the first question. So I got, when one says any person you think of will usually be 6 degrees away from you, could you explain that? Yeah, so that was a very famous experiment that was done few decades back actually, to find out how one person is separated from any person in the world. So on an average, they found out that one person is 6 degrees separation away from each other. So for example, let's say this is you, and someone, okay, which knows somebody else in any other country which you don't know. For example, you don't know, and let's say this is me, okay, here again in India, and that person might be knowing some other person, and this person might be knowing any other person, and he would be knowing, he'd know me. So if you see the separation between you and me, so there are 6 degrees of separation, right? So 6 is not a exact number. I think it was 5 point something, but yes, on an average, when you say any two person in the world, they are 6 degrees separation away from each other. Okay. Yeah, so I'm taking questions from Q&A. So I'm getting one question, how is network science different from recommendation system and learning? So recommendation system is a very broad area. It's a very vast area, and you can use any technique for building recommendation system, and network science is one of them. Okay, network science is not the only way you can build recommendation system, for example using even decision trees, or maybe even random forest models using supervised classification techniques as well, or you can build recommendation systems using matrix factorization techniques like SVD, singular value decomposition, or you can build recommendation system using clustering, or you can build recommendations using collaboration filtering, for example, right? So it's a very vast area, and network science is one of the way through which you can also build recommendation system. Let's say you have a bipartite network. For example, this is one partition, and this partition is all, let's say, users. Okay, and let's say you have another partition, and this partition or these nodes are all movies. Okay, so for example, this user A has watched this movie ID 1, and he or she has rated this movie ID as 5 out of 5. Okay, and that's why there is a connection. And he or she has also watched movie ID 2. Then this is another connection, and this is another connection over here. Okay, and this is another connection, 3. Now, if let's say he or she, this is D, user D, and this rating is 1 out of 5, and this rating is 1 out of 5. Okay, now if you see user A and D, they are very similar to each other because both of them has watched movie 1 and 2, and the rating schemes or patterns are also similar. A like movie 1, D also like movie 1. A dislike movie 2, and D also dislike movie 2. So if A and D are similar to each other, and let's say D has also watched movie 3 and he or she has rated this movie as 4 out of 5, that means I should recommend movie 3 to move to user A as well. Okay, so this is one application, another application of network science, which this kind of network are known as bipartite network. Okay, so these networks are also can be used for building recommendation systems. So long story short, to answer your question, there are many different ways to build recommendation systems. Network science is one of them, and recommendation system is not the only use case of network science. You can do many different things using network science, which I have mentioned to you as well in this previous notebook, where we have done portfolio construction, okay, in finance. So network science is everywhere. Depending on business case, you can do many different, you can solve many different kinds of problems. Okay, so I'm getting a question how to start with this network science. Looks like we need strong basics of this network. Can you please suggest some resources where we can start? Yeah, definitely. So here, if you see this particular book, which I generally follow when I followed when I started learning about network science. This is a book by Albert Barabasi. So if you, and this is a very interactive book, and if you go see its content, it has introduction to network, then graph theory, random network, scale-free property, evolving network, degree correlation, what we have discussed in today's session, then network robustness, community detection, spreading phenomenon, and so on. So this will be a very good book if you want to start learning about network science. And then you also once you learn this theory, you can learn some syntax in Python using network X library. So just go through the official Python documentation of this library, and then you will be able to see many tutorials and on how to use those theory on any kind of data sets. Okay, so now the next question is okay. Yeah, so can you advise some links for connect? Yeah, so I already have given a link. One is the network science book. Another one I also highly recommend is you can go through this Snap website as well, Stanford Stanford Network Analytics platform. So this will also give you lots of resources. First, you can get all of those data sets, and if you click on these projects, so here you can see all of these projects. That is all on network science, and you can also learn what's going on latest in this particular field or area. Okay. Okay, so next question is how network science is different from data science, where network science is used, where the same ML, DL, and NLP algorithms are used in my query. Yeah, so network science is a kind of part of data science, I would say, because in network science, if you compare network science with all the other different algorithms in data science, or especially if you talk about machine learning, let's talk about regression problem, or let's talk about classification or clustering problem. So all of those algorithms are used on a tabular data or in a structured data set. But in network science, to be able to use network science, you need the data set in the form of a network. Okay, so if you can convert a structured data set into a network data or into a graph data, then you can use network science on top of it. For example, in the movie recommendation system, how the data set was. So the data set has three columns, right? You have user, and then you have movie, and then you have rating, right? So from this structured data set, we can create a network where we can create a bipartite network, right? So let's say this is one partition, and all of this partition are user, and you have another partition. All of these partitions are movies, and then you can create an edge between them based on the rating. Okay, so once you can create once we can create any structured data or tabular data into network form, there you can start using network science. Okay, then the next question is, can you suggest importance of maths in network science and some resources to understand maths behind this? Yeah, so network science is very mathematical, and so this book which I have just recommended, I think this will be sufficient or enough for you to understand those maths under the hood. Okay, quant trading. I got one question from quant trading versus network science trading. Yeah, so quant trading is again a very vast area. So network science is one, way to analyze, to build strategies for quant trading. Okay, so basically you can use network science as a tool to develop some kind of strategies. If you talk about in financial modeling, you can use network science for risk management. You can use network science for portfolio construction, which the notebook that I have shown just a few minutes back. And you can also use network science for coming up with trading strategies. So network science trading is a kind of subset of the entire quant trading ecosystem. You can think of it like that. Okay, so I got a question from Vipin. He's asking, can we get link to reference data set? Yes, definitely. So this is a link to the data set. I mean, if you go to this website, you'll see lots and lots of links to different kinds of data sets. Okay, or even you can go to Kaggle as well and just search for network science, network data sets. You'll get lots of data sets there. Okay. Okay, fine. So I got one question that it said it mentioned 50 dimensions, even though 3 columns mentioned for the movie recommend. Yes, so actually in this particular example, so these are all 50. So every movie, okay, if every dot, okay, every dot is, or every data point is a movie, and each of this movie is represented by a 50 dimensional vector. But we cannot visualize a 50 dimensional vector on a 2-dimensional screen, right? So that is why we have converted this 50 dimension into a 3-dimension using a dimension reduction technique called PCA, that is principal component analysis, so that it is easy to visualize. Okay, and these are those 3 PC components. So this green one is PC component number 1, this blue one is PC component number 2, and this red one is PC component number 3. Okay, so this conversion we have done just to visualize this entire embeddings of movies, and from there you can, whatever we have discussed, like how to build a recommendation system, so you can use that strategy to find out which are the nearest neighbors, and if a particular user have liked this movie, then you should recommend these movies to that particular user. Okay. Okay, so fine. So let me take a few more questions. Okay. Okay, so I'm getting a question that how useful could network science be for someone who is working as a data scientist? It can be very, very useful. It depends on what kind of domain you are in. So for example, if you're in supply chain is all about network, right? You have hub and spokes models, right? So how do you, optimize your network? Or if you talk about finance, for example, in finance as well, there is an interconnectedness property of all the financial securities. So if one goes down, what will be its impact on the remaining portfolio, right? So it depends on which industry you are in. Or from e-commerce as well, e-commerce like Amazon or Flipkart, which items goes together in a basket, or which items are bought together. So if there are one pair of items, and they are always bought together, so there will be a connection between those two particular products, right? So depending on what kind of which kind of domain you are in, it will be much helpful. For example, if you are from any of this domain, which in this particular website which will mention here, like information network or communication network or web network, Amazon network, right? So if you work with in this kind of domain, then network science can be very much helpful for you. Okay. So yes, so again, I got another question from Vipin. Apart from recommendation system, what are the applicable areas of network science? So again, I have already answered. In finance, I have given you some example. In people analytics, in HR analytics, I have given one example that you can find out which employees are very important for you, and so on, right? And in social media analytics, again, network science is very helpful, right? So there are so many domains. So next question. This is the last question that we'll be taking. We're already We're already on time. The last question is, what are the Python libraries you need to refer for network science? So Python library that I have mentioned already, that is network science. Okay, sorry, network X. Network X you can use to use all of those algorithms, like those centrality measures and those features of the entire network, like shortest path, then clustering coefficient. All of those are already implemented in those network science network X library. Okay, that's it from my side. I hope you enjoyed the session. Thank you very much for joining in, and yeah, enjoy the rest of the day. Over to you, Raksha.
Yes, I guess most of the relevant questions are already covered and we are on time. So we will wrap up the session here. And thanks a lot, Bhaskarjit, on behalf of Analytics Vidhya. I would like to thank you for devoting your time and delivering such a great session. I'm sure it was insightful for our audience and it was really comprehensive for lots of experience level. And hopefully we can conduct more sessions with you in the future. Also, I would like to request attendees
Thank
to
you.
please participate in the feedback poll as well. It helps us to conduct such more sessions with you. Okay, so we will be back with another session of the Data Hour on 16th of August, which is on understanding AWS virtual private cloud concepts. And the link is in the chat section. Okay, so we will wrap up the session here. You can copy all the links from the chat section. Till then, everyone, keep learning and bye-bye.